Hey y'all, this is going to be the first video in a series that I want to start, kind of covering some of the fundamentals of video synthesis, specifically as it pertains to the LZX ecosystem. Um, I know that there's not that many super direct and clear resources out there for kind of getting started with this stuff. So I was hoping to bridge that gap a little bit with this series. So without too much dilly-dallying around, let me just jump right into it. This video is going to be on encoding and decoding RGB. So we'll start off real quick just describing the basics of a composite video signal. As you can see, I'm using component output here, but let's just pretend it's composite for now. So composite signal usually consists of three different general pieces of information. You have your brightness information or your luma, and that's basically just the intensity of the video signal, and it's all that really exists in a black and white signal, including the sync information, but we'll get over to that. So first you have your brightness or your luma. Then you have the color or chroma information. And then finally you have your sync information, and that's what tells the receiving device, like a TV, where to stabilize the picture horizontally and vertically. Um, and so all three of those pieces of complex information are typically encoded into one signal known as composite, which you usually see on a yellow jack. It's kind of hard to see here, but you can see them here. Um, and so that's it's a pretty complex signal. And when you're working with video synthesis, at least in the LZX ecosystem, you're sending more simple waveforms into the encoder. So, for example, you might just send a simple sine wave, but if you were to send a sine wave directly into a TV through the composite input, you probably wouldn't get anything interesting. Most likely, you would just get a black screen because that doesn't even include the sync information that's required for the TV to properly display the picture. Um, so now we'll talk about the basic components of LZX standard video synthesis. Things work in red, green, and blue color space. So when you go to encode the picture, you send information into either the red, green, or blue color channels, and that corresponds as the brightness and color information for each of those specific channels. Um, so we'll talk first about how encoders typically, some encoders will just work individually. So if you were to send a signal just to the red input, then the output on the screen would just be red. Um, but this encoder specifically has what's called normalization. And so when the jacks that are below the top jack aren't plugged into anything, then they will automatically receive the signal from the jack above it. And so what that looks like when you plug something into just the red channel is just your black and white picture, because that signal will normalize down to the green and blue channel and basically filling all of the color space. So we'll take a look at what that looks like. Let's just do a shape for now. I'm just adjusting our contrast and brightness here. Try to get it to 0. So that's supposed to be black and white, but you can tweak the contrast and brightness of each color channel, so it's a little off center, but let's pretend that's black and white. And so what's happening right now is this shape is getting sent to the red channel, and it's also normalizing down to the green and blue channel, and the result is a black and white output. Now, if we were to, say, send it just to the green channel, then the result would be a green and blue output, combined output. Or if you're just to send to the blue channel, then it wouldn't receive anything in the red and green. And now you see it's truly blue output. And so what that might look like as a full color picture, why don't we just try sending something to here and putting all of our RGB plugs in here. You see, you get a full color picture. And so that's basics of encoding. So you need a device like this that takes your red, green, and blue color signals and adds that sync information and properly encodes the brightness and color information into typically a composite signal, though I am using component here. If you want to get me to get into other video signals, I could make a video specifically talking about that. Just let me know. But now that we have a little better understanding of encoding, we'll talk about decoding. And it is exactly what it sounds like, the exact inverse of encoding. So you take a composite signal and put it into your decoder, and it will spit out your red, green, and blue color information. And this specific encoder also has just a luma output, so that would just be your black and white output or monochrome. So right now, I have plugged into my decoder already a cheapy little backup camera pointing at a nice little telephone booth. So let me see what that looks like. And so just like that, you have your full color output. And so what's happening here is that composite signal is coming um, from the backup camera. It's coming into the decoder, and that decoder is essentially stripping off that sync information and taking the brightness and color information and converting it into separate red, green, and blue channels. So if I were to just send just a red channel right now, let's just unplug green and blue for a second. You'll see on here, what's coming out is just the red information from the picture. But because these jacks on the encoder are normalizing down, it appears as a black and white picture on the output. And adding back green looks more normal, but you see it's a bit it's missing that blue portion of the color information. Adding back blue. And just like that, that's our full color picture. And so that was just kind of a basic on the encoder and decoder portion of video synthesis system. In the next video, I want to start talking about oscillators. So stay tuned and we'll get there.